Hi, and welcome to the latest webinar in the New World Summit AI webinar series brought to you by Inspired Minds. We are delighted that today's webinar is produced in partnership with Siemens and focuses on AI in action. So today we'll be looking at two different examples of how AI is effectively being deployed within manufacturing. My name is Jane Zavalishina. I'm with a company called Mechanica AI, and I will be your moderator for the next hour. Please don't forget to send through your questions for our speakers, because they are keen to hear from as many of you as possible, so keep them coming. And keep in mind that the questions will be anonymous, so you don't need to be shy. You can ask all kinds of uncomfortable questions if you want. And now, let me introduce you to our first speaker. It is Thibaut Deassi, and he is General Manager and Global Head of Digitalization and Automation for Siemens. Thibaut, nice to see you. Welcome, floor is yours.
Thank you, Jane, for your introduction. People, I hope you love fast cars. I'm gonna take you on a ride.
I think first and foremost, with the Ghibli, we wanted to. The Ghibli adheres to the core brand values of Maserati, being Italian style, dynamic performance, and refined luxury. The challenge, obviously, in terms of launching higher volume cars within a modern manufacturing facility, state-of-the-art manufacturing facility, is to retain that bespoke feeling within the cars, which is very much appreciated by our clients.
Being able to work in a digital twin is a significant evolution compared with the past. By using integrated software such as NX and Teamcenter, we can have an interface of all the teams developing the project on the same mathematical base. This allows us to reduce analysis times and to avoid possible errors caused by miscommunication between the different teams.
We can say that one of the strong points of Siemens is the fact that we offer a product portfolio which covers both the manufacturing and the engineering side. And what's more, these products are also tightly integrated.
The Technomatics tools are above all useful in the analysis of the product and in the simulation of the product line. Earlier planning and development know-how is thereby incorporated and implemented in the overall design. The aim was to produce 3 times as many cars than before, while maintaining the same level of quality, which is obviously higher, simply because it is a Maserati.
Well, CAS is an integrated system used by the entire Fiat Chrysler Automobiles group and is also installed in the Maserati plant. It facilitates the management of the plant with Siemens PLC and HMI hardware with WinCC and Step 7, delivering all the diagnostics of everything that happens in the plant in real time. So Siemens technology helps us to be more efficient and have better quality management in the production plants.
The expertise is not only in the tool, so not only in the software, but above all about how to use the software within the setting of Maserati and FCA, because that is where we really make the difference.
I cannot see your faces, and I am sure you are wondering, come on, Thibaut, Siemens, Maserati, wow. I'm sure you know us. I'm sure you know us through power generation and transmission. I'm sure you know us through medical diagnosis. I'm sure you know us through infrastructure like mobility. We are having leading position in electrification. This is where our roots are. We are market leader in automation. We are automating the factories of our clients, and we are driving forward digitalization. We are transforming the manufacturing data into valuable insights by leveraging our digital enterprise portfolio elements together with edge computing technology and artificial intelligence. We have been running through 4 industrial revolutions. The first one, water and steam, brought production manufacturing equipment. The second one, the T model from Ford and electricity brought the mass production. The third one, it's about electronic, brought the first programmable logical controller in the manufacturing space. And from now until today, all the low-hanging fruit have been captured in terms of manufacturing improvement. And today we have reached a plateau in terms of continuous improvement. Now we are in the 4th industrial revolution, digitalization. Digitalization is about human and devices connected. It's about making data available in real time across the entire value chain. And here, in order to make the change into the plateau, AI is changing the what's possible. Our customers are asking us for a lot of requirements. How Siemens could improve their quality of their products, the quality of their processes, how they could turn the data into valuable insights, how they can reduce their time to market. And I am sure you have, or your customers, or the customer of your customers, you have also similar requirements. And all these requirements, they want the answers at the same time. For example, in the automotive industry, being automated for decades, they are still facing challenges. How they could predict the quality of their products to avoid inspection time. How they could detect the spatter to reduce rework. And how they could detect anomalies to save process costs. And maybe in your own words, you are also wondering how you could solve those challenges. How we Siemens are answering to these requirements, we are having a holistic digitalization approach. We are bringing the real world together with the virtual world. In the Maserati video, the digital twin of the product is the representation of the Ghibli Maserati car, integrating mechanical, electronic, and electrical components. And then we go to the digital twin of the production. This is where we're gonna bring the feature of the product, and we're gonna simulate the whole manufacturing processes by incorporating human behavior, robotics, to make sure once we move into the real world, the production will behave as expected. Then we're gonna move into the real production. And here our clients are using our totally integrated automation to engineer their machine, to engineer the automation of their manufacturing line. And what we're gonna do, we're gonna connect the engineering environment together with the digital twin of the production to validate the engineering, but also to make sure that we're gonna get the right throughput time, we're gonna get the right cycle time, and we're gonna avoid all possible collisions once the production is running, all in a very secured environment, because industrial security is at the heart of our product portfolio. Then the production is running, and the production is running using our manufacturing operation management portfolio. This is where we have our manufacturing execution system, our quality management system, as well as our scheduling and planning. Once the production is running, we're going to feedback the data through our cloud platform to the digital twins to continuously improve the overall process. We are enabling our clients to have a seamless horizontal integration along the entire value chain. But we, Siemens, we are also converging the operational technology with the information technology. What you can see here at the bottom, this could be your own power plants. That could be the body shop of Maserati. Here at the bottom, that could be the elevator that brought you this morning to your office or to your home. That could be the turbine plants of your customers. On top of it, we have our controllers. We have our SIEMATIC portfolio with our SIEMATIC PLCs, with our industrial PCs, with our SCADA system. On top of it comes our edge computing. For us, edge computing is not a simple gateway. For us, edge computing is about openness, is about data and device security, is about local pre-processing of data at the edge of the network, and is about running machine learning and AI model close to the machine. On top of it comes our cloud platform. And here we have our MindSphere. On top of MindSphere, we're gonna get the data, we're gonna aggregate the data, and we're gonna perform correlation, statistical analysis, retrain all the models, and bring it back to bring it down to execute it on our edge devices. Our clients are also leveraging Mendix to develop in an efficient manner and productive manner applications to create business impact on their shop floor. This is our overall ecosystem. In our Maserati body shop, we have our automation. We have our SIEMATIC PLCs. On top of it, we have our edge computing. On our edge computing, we are running applications or AI-based applications to bring productivity. Our edge computing are connected to the cloud, so we are cloud agnostic. But here what's really important is our edge management system. This is a centralized system to deploy across the entire factories, for example, security upgrades, for example, firmware updates, distribute applications across the overall plants. We are also enabling our clients to bring their own applications, AI-based or non-AI-based application, into our store to deploy those applications later on the shop floor. If we look at the entire automotive value chain, we do have in those different shops identify different use cases. Surface defect inspection in the paint shop, for example. Unseen part sorting in the powertrain. These are those different use cases, and the one that I highlighted, I'm gonna walk you through in a couple of minutes. And I am sure you have been using Siri or Alexa in the past 24 hours. You have been using Siri to find the nearest French restaurant, or Alexa to play the latest Katy Perry song. Well, in our words, we have used SAM, Semantic Assistant for Machine. This is an application where we are leveraging natural language processing and knowledge graph to help the field maintenance engineer to perform in an efficient manner his maintenance task. We're also applying AI in the grasping process to improve productivity in the processes. We're also leveraging audio in the assembly process. Now, let's have a closer look on those use cases and how we have been implementing them. I would like to start with defect prediction in the die casting process. Today, in the die casting process, the parts are being detected at the end of the line, if it's defective or not, either manually or using visual inspection. On average, the defect rate is between, I would say, 2 to 4%. That can go up to 10%, which represent around 10,000 scrap parts per year. What we are doing is we are applying AI in the die casting machine. So we are identifying the key process parameters that are affecting the throughput of the die casting process. So we have an AI application that is deployed and run on our edge devices, and our edge devices is connected to our SIEMENS PLC in the shop floor. Running this AI application, it helps to improve or to reduce the process costs by 40% and to decrease the defect rate by 40%. And I'm sure you also would like to hear about cost saving and productivity. So imagine all these savings, what would represent in your own words in terms of productivity and efficiency measure. Let's look now at another use case, which is in regards to spot welding. For a car manufacturer that is producing 1,200 cars per year, each car on average, we have 5,000 welding points. So in total, there is around 6 million welding points to be inspected per day. Today, the car manufacturers are leveraging ultrasonic technology to detect the bad welded parts, the bad welding points. But they could detect around 90% of the number of the welding points. What about the 10%? We know today that the car manufacturer allows only 5% of undetected bad welding points. So what we are doing, we are combining process parameter together with inspection results and applying AI to predict the bad welding points. And this is helping our customers to increase the production takt time, but also to improve the overall effectiveness of the welding process in the body shop. I am wondering how many of you have heard about Mino Automotive. Mino Automotive have been implementing the overall digital enterprise portfolio with our AI technologies. They have been moving from a simple line integrator in the automotive space to an intelligent manufacturing solution provider. This helped them to reduce the engineering time by 1/3 and to reduce the commissioning time by 50%. Another case is about automated guided vehicles, or AGVs. So today, at some of our customers, the AGVs is being charged at the end of each manufacturing cycle. You should know that 1 minute stop of a single AGV result in 500 euro per minute. It's a huge amount in terms of production costs. So what we have been doing is we analyze the AGV alarms report. We are getting data from the charging station, and we are developing an AI model to predict accurately when the maintenance has been done. When do we have to send the AGV to the charging station and to prevent AGV from being stopped for insufficient charging. We also are applying artificial intelligence in our own factory in Hamburg. So in Hamburg, it's an electronic manufacturer. This is where we are producing our SIEMENS product portfolio. There we are having X-ray machine for inspection. This is a very expensive machine. And what we are doing, we developed a vision-based algorithm to predict the quality of the PCBs. AI helped us to reduce by 30% the number of tests being performed inside the X-ray machine. We have reached 100% quality rate, and we reduced our investment by $500,000. So in all these use cases that I showed to you, AI is offering a huge potential for the manufacturing. AI will enable human and machine to collaborate to make operational processes much more flexible, much more efficient, and enable a human being to take the right decision. So the operator will have the power to make the decision that influence the manufacturing processes. And now, before moving into the Q&A, I want you all to look around you and identify one object that uses AI. That can be your smartphone, that could be your kitchen appliances. Please identify it, and I want you to go into the chat room and type it. Ready, go. Thank you. So I have a message from Alexandra. Smart vacuum, that's great. Honestly, Alexandra, I have no idea what kind of AI is being implemented there. Oh, we have Roberto with laptop. Smart TV. This is a great a great example where do we have natural language processing being implemented there. Thank you, Costa. Sergio, Apple Watch. That's great. In fact, with the Siri technology, this is a good appliance there. And now, I want you all to think about how those identified objects have been produced using AI. So I have also ice cream coming from Roberto. In fact, in the ice cream manufacturing process, we have implementing a vision inspection system to look at the quality of the printing on the packaging machine. I would like also to thank Mike regarding the Google Assistant on the Android platform. And honestly, Alexandra, I'm gonna check this afternoon the smart vacuum and to be able to understand what kind of AI have been applied there. Thank you very much for listening to me. And now I would like to ask Jane to move to the Q&A. Thanks a lot.
Yeah, thank you, Thibault. We just started to get the questions, so it seems that our audience needs a bit of time to digest what they just got. So using my position as a moderator, if you don't mind, I'll start with my own question. So I would like to ask you this. You showed us how AI can be used in particularly the automotive industry and how Siemens does that. But of course, the number of cases and potential applications is unlimited. I think it's really a lot. It's hundreds, thousands probably for just one manufacturer. What do you think is the most impactful application or use case of AI in manufacturing? What is the biggest thing we can do, or maybe a few things?
From you mean from a use case perspective or from the approach perspective?
No, from a use case perspective. Well, I'm a practical girl, you see. I'm always asking about what for.
Okay, great. So I mean, I would like to bring it back to the AGV example. I mean, here you see, one minute stop in such advanced, I would say, automated industry from the automotive. It costs 500 euro production costs, right? And this industry has been automated since decades, and it's in a continuous improvement processes. I would say each of the use cases that is connected to a clear and concrete KPI in terms of challenges and pain point for the customer, which has a return at the end of the day, that will have a huge impact at the customer side. So what we are doing, actually, we work together with our partners to really understand the pain points and to really understand where the data are, and figuring out what are the KPIs that they would like to achieve in order to reach a certain productivity rate.
Right. So basically what you are saying is the impact or the most impactful cases would probably depend on a specific customer, right? And that's exactly your job at the start of the implementation, to figure out which ones are most efficient. Is that right?
Exactly. And then
it brings me to the next question then. Yeah, sure.
Go ahead.
No, so sorry.
Oh, okay. So even in fact, I have also another example that came to my mind is the AGVs in those huge warehouses, you know, like Amazon. I mean, Amazon, they are making a fantastic job in applying AI in terms of reaching efficiencies, in terms of energy saving, and so on and so forth. This is, I think, one of the also important impactful use case that we are seeing today.
Right. So as I said, it brings me to the next question we already got from audience, actually a combination of two questions. So if it is so important to figure out what is it exactly you're solving, right? What are the KPIs? So is that right to guess that it's probably is the biggest challenge when you work with a customer when implement AI? And is that the reason, or there are other reasons to kind of slow down the adoption of AI in manufacturing? Because, well, maybe it's a little bit better in automotive, but in general, manufacturing is not that fast in implementation. So first question about biggest challenges, right? And second, what do you think is a problem with adoption, and what are your predictions about future of AI manufacturing?
Yeah. I think today, if you look at our overall, I mean, the overall pipeline that we have today, and we as Siemens, we are having a leading position in automation, but we do see, I would say, 30. I mean, if on a scale of 100, right? We do see 30% of customers, they have no idea what AI could bring to them. 50% of our customers, they are applying AI to experiment, and they do see to experiment and to see the benefits. And the rest, 20 to 30%, they are really forging ahead. The challenges that you are having today, or that the industry is facing today, I would say are categorized on different aspects. The first is the resources, having, let's say, the data scientists, the machine learning experts in-house. Actually, the population of the data scientists is pretty much limited. Second is data. Actually, data is being fragmented. So this I would say the first important step that the manufacturer has to carry on in terms of standardization and in terms of data integration across the different layers that I have described before. Digitalization starts always with standardization. And once we have all the data and identified those use cases by analyzing the whole value chain, then the AI comes into the game. We are still, I would say, as I wrote here, the AI in manufacturing has begun. We are still at the beginning of the journey, but I'm pretty much confident in short term the impact within the manufacturing space, not necessarily in automotive, because we do see also cases in the food and beverage, you know, in the brewing industry, in the beverage, in the packaging industry. They are also applying artificial intelligence, but it will take a little bit of time.
Sure. Well, we have just 1 minute, but to finalize this, so we are now starting. We know what to do. We need to work with data, and we need to implement the most efficient cases. And finally, at some beautiful future, we'll have this self-orchestrated factories of the future. When do you think it happens?
So
which year? Just a number. Give me a number.
And this is the reason why we are bringing our edge ecosystem. At the end of the day, with our semantic edge ecosystem, we are bringing partners, clients together, because we believe in openness. We are bringing them together that help them to leverage from each other in terms of manufacturing processes. So which means if at customer A we have implementing the battery prediction from the AGVs, this AI application or model would be available in the store, so that probably another customer would be able to retrain it based on its own feature and improve, let's say, the prediction and the accuracy of the model. I think it's a matter of ecosystem. As at the end, we need to work all together to bring the manufacturing to the next level in terms of artificial intelligence.
Okay, thank you very much. Thanks, Timo. So now, next up, we have our next speaker, Romaric Redon. He's an artificial intelligence fast track leader from Airbus. So please, Romaric, the floor is yours. And let me remind you guys that we're still waiting for your questions. You can address them to Romaric. So, yes.
Hello, everybody. Thank you, Jane, for the introduction. So, yes, I will. So, I think you all know Airbus for flying product, which we manufacture, commercial aircraft, helicopters, military aircraft, whatever they are, transport aircraft or fighter. Also, we are involved in manufacturing satellite, on doing a lot of services associated to satellite imagery, and also we are building UAV platform. What you might less be what could be less obvious for you is also that we are building digital platforms. So we have one digital platform which is linked to commercial aviation, Skywise, and we have another one which is One Atlas linked to space imagery. I'm mentioning this digital platform because they are a key enabler for artificial intelligence, because we are gathering on the one side in Skywise all data coming from fleets of aircraft. And in One Atlas, we are gathering all satellite imagery, which we obtain through a constellation of satellite which we operate. And also there are other digital platforms linked to space imagery, but I won't go into the detail of them today. And these platforms are based, they are cloud native platforms. So really to build them, we have to embrace big data, cloud, and AI. And I will give you a flavor of what we can do with them. So first, what about artificial intelligence? So you can spend days, weeks to discuss what is artificial intelligence. And inside Airbus, we like to embrace this very wide definition: systems that perform actions that, if performed by human, would be considered intelligent. What is interesting with this definition is that it shows that it is a moving definition. So in fact, what we call artificial intelligence today might not be called artificial intelligence tomorrow. And in fact, it's already the case that, for example, rule-based system, some of them would argue this is no more artificial intelligence because it does not look intelligent anymore. So I don't want to enter this debate, but what is interesting is to look at what kind of actions we can really assist or automate with artificial intelligence. So all comes back to perception or decision action. So when we are about perception, it's linked to computer vision. If we deal with image and video, time series analysis, if we deal with time series, natural language processing, if we deal with text and also speech, potentially. And all of that is using pattern recognition as a transverse approach, potentially. Then when we look into the decision making, there are mostly two classes. One which is offline decision making, doing planning, scheduling, and also decision making in closed loop system, which is more linked to control and robotics. And so I will give you example of these applications inside Airbus. Something I want to say is we speak a lot about machine learning, deep learning, which is data-based AI, and it's really true that in the last years, I mean, this technology have enabled to reach a new level of performance for all the perception action, especially. Still, symbolic AI, rule-based system, expert system, case-based reasoning, I mean, on many more technologies are still something which we use a lot. And especially for the decision making, still this is very much used. So in Airbus, we do embrace both data-based and symbolic AI approach. And I want quickly to make a note. So some people, sometimes you hear people saying AI is enabling a lot of things, which is true, but it's not AI which is doing everything. So in fact, we are not building a system, a big AI system to do everything. The approach in all what I will show to you is in fact AI is one out of many technologies which are used inside a complex architecture. And I think as industrial, I mean, our added value is really to engineer also the right architecture to have the right property. So when we speak about having AI in flying platform, for sure we have to deal with redundancies, with the right safety architecture, so that whatever new technology we use, AI or not, we are using it in a way that it is safe and certifiable. So where we are in Airbus for AI adoption. So AI is an ubiquitous technology, so we can use it for a lot of applications. So we can use it in to boost design and testing, to do surrogate modeling, to do planning and scheduling of the test. We can increase the performance of our flying platform because we can better optimize aerodynamic property, for example, and reduce the drag. We can increase the performance of our industrial processes. So this is related to the previous talk. Also, we use AI a lot for visual inspection, for planning and scheduling of manufacturing processes, for doing predictive maintenance for tools, machines, and parts, so quality. Also, another area is really improve the flying platform's operation. And this is really about predictive maintenance of the aircraft itself, or the helicopter, or the satellite. I mean, having uptime getting the uptime to the maximum, and reducing downtimes. Also, we can plan flight operation using AI. We can develop a lot of digital services. So you will get later on example. I mean, using all the data we gather about aircraft or coming from space imagery, we can develop a lot of digital services. And last but not least, we can try to move to more autonomous flying platforms. So you can see some stuff in orange, which are showing you a bit where we are. It's a kind of a relative scale. So where we are very advanced today, and we are already delivering AI to our customer, AI solution to our customer, is in the domain of predictive maintenance of aircraft, on the domain of space imagery analysis. So these are areas where we are very, very advanced, and we are professional, I would say. There are other areas where we are less advanced, and I will give you some example, not covering all of the domain. You can reach out to me because I have dedicated presentation on each of the domain. So first stuff I want to speak would be about computer vision example. So the first one is about extracting information from space imagery. So here you have several examples of extracting boats from satellite imagery, and you will have even a classification of these boats. You can extract aircraft, you can extract cars, and in fact there are a lot of applications. You can, for example, build based on extracting the number of cars on a parking, especially during COVID crisis. It was used to really measure activities of the factories, doing intelligence, counting cars on parking. So it's a very easy way to know what's the level of activity inside a factory. And so this is some example. So we do a lot in terms of object detection, also change detection for many verticals. So there are also verticals which are linked to agriculture, to deforestation monitoring, so environment and so on. So this is one area where we are really in full deployment mode of AI, space imagery analysis. I will speak about another example, which is more upstream, linked to computer vision, which is using vision-based navigation. So getting an aircraft to do the taxiing, the takeoff, and the landing only using vision. And I have some, I mean, we have a demonstrator which actually achieved a lot of different world premiere. So I will now show you a video. So you have the link in the chat if you want to run it on your side. So this is, okay, sorry for that. I have to pause it like this. So you are in an A350 cockpit, and this is actually a video of the first autonomous takeoff of an A350. So you will see, so this test was done this year, and so the only stuff the pilot is doing is actually managing the power of the engine, and then the algorithm will manage really aligning the aircraft on the runway and really getting the takeoff performed. So you will see inside the video that progressively the algorithm is aligning the aircraft, and you will be able to notice that so the pilot is not using the stick, which is the way it would normally lift the aircraft. So he's about to do it, but the co-pilot is telling him, "Oh no, let it go." And so this was the first autonomous takeoff of a commercial aircraft realized. And in the same project, we had several other world premiere. So another one that I will show on the next slide. Yeah, another one is the aspect of the landing. On here, I mean, I'm just putting a tweet because our CTO, Grazia Vittadini, tweeted the success of the first vision-based landing in closed loop of an A350, which means pilots were doing nothing, just getting the algorithm to land the aircraft. And quite luckily, I mean, Yann Lequin, who is someone who is quite well known in the AI community, retweeted our CTO tweet, which makes this video quite popular on Twitter. I will just show you the video. You have also the link. So here you see this is a landing sequence in Toulouse, and you have the runway, which is detected using a deep learning algorithm. And we have a comparison with the ILS, which is the normal sensor used to land an aircraft. And we have achieved a very good level of accuracy to actually do this landing, and we've made dozens of autonomous landing in this project. So this is really a world premiere on a very important milestone for Airbus. So coming back to the presentation, sorry. Yes. Yeah, we have another example which is linked to air-to-air refueling, and it's still an example with computer vision. Here the topic is about refueling an aircraft, a fighter aircraft with a tanker. So once again, AI is used to detect, AI is used not alone, but as part of a complex system to detect the aircraft shape and to enable the rendezvous somehow between the tanker and the fighter. And you will be able to see that this is working in daylight. So this is an example. I've just paused it so you can see it. So you see the shape of the aircraft on the boom, which is detected, and then you have the control which are performed to perform automatic contact. And this is something which work with whatever lighting condition, which is the difficult aspect, with a lot of reflection. It also work in the dark, and this was as well world premiere for Airbus. Sorry, the presentation. Okay. So also we use visual inspection in the manufacturing process. So the example here was, I will skip it, but the example is to use a UAV to fly over an aircraft to detect the defect. There is also a video associated to that. You have the link in the chat and you will be able to look at it. So I want to cover the other aspect. So we are quite advanced in terms of using computer vision. Also, we are very advanced about using time series analysis. It's less sexy to show, but we are collecting a lot of parameters on aircraft through the Skywise platform, and we are able to do a lot in terms of doing anomaly detection, trend monitoring, prognosis for predicting the degradation of parts and doing then predictive maintenance. And all of that is very advanced, even though we have still to incorporate a new algorithm, and we are building an internal forge for time series anomaly detection algorithm. The topic of virtual assistant is also a topic which is important to us. For several use cases, I've put two there. One which is virtual assistant in the cockpit, and we have another virtual assistant which we brought to space. So astronauts have a virtual assistant with them on ISS, which is called SIEMENS. And both of them are based on knowledge extraction, capability from documents, then building a knowledge graph which you can question with question answering technique. And there are a lot of topics also regarding speech recognition in noisy environments, such as inside the cockpit. In terms of decision making, this is an area where, in fact, we have also developed some toolbox internally to take the best of existing solvers which exist to plan under uncertainty, to plan for flight trajectory, taking into account uncertainty of the weather forecast, and also to plan satellite acquisition, for example, also with uncertainty about the weather. By the way, this platform is open source. We've decided to open source this platform, so you have a link there. It's not yet fully, the documentation is not fully yet there, but it's an ongoing process, and you can already have a look at the code that will be open source. So last, I was eager to tell you a bit about what's under the hood, because you've seen some very interesting realization, but still, how do we scale AI is a key topic. And for that, we have been working, we have inside Airbus the Digital Transformation Office, which we are working with, which has been very active on several fronts. One is really the aspect of changing, getting the social acceptance for AI, implementing new way of working, really working in sprint mode, implementing multifunctional teams, which are key, because it's not only about having a data scientist. You need really data scientists, to data engineer, and many more to work closely with domain engineer and so on. Also to push for internal maker spirit, because an AI system is not something you buy. You have to educate it. So you have to have a way you can learn, and then the AI will come on top. So you have really to be with a kind of maker mindset to be successful, and really to upskill our workforce into AI. On the technical aspect, for sure, we had to build data lake. We had to put a lot of labels on this data lake. We had to get infrastructure that would scale using cloud technology, to implement machine learning ops, to facilitate inner source sharing, to build reusable AI services, and to have a marketplace of reusable services. So all of that is behind the hood to enable the example you've seen. And also still we have to do a bit of AI research. So Airbus is very active in many research institute, especially working on trustworthy and safe AI, because AI is very efficient, but it lacks the ability of really providing good guarantees on the results which are obtained. And therefore, for us, it's key to invest on research on this aspect. So as a conclusion, in order to take the questions, I would resume where we are and where we want to go in Airbus. So on one side, we really want to scale AI to boost our competitiveness, and you've seen many examples where we have already achieved world premieres. And on the other hand, on the research axis, we want really to be a world leader in safe and trustworthy AI research. And therefore, we invest in a lot of research initiatives, which are key for us. So thank you for your attention, and I'm happy to take questions you would have on this presentation.
Yeah, thank you very much, Romaric. It was quite exciting. And the first question, easy to actually understand why. I think the most impressive part was about this autonomous takeoff and landing, probably especially landing, right? It should be the hardest part. So it really looks very impressive. Congratulations. And the question that comes from our audience is, well, it's apparently a great technological achievement. The question is how it's going to work in practice. So do you expect for some foreseeable future for takeoffs and landings to become autonomous, or it will be just used as some assist in, some special situations for the pilots? So how do you see this applied in actual practice?
Yeah, I mean, the target is Airbus has a roadmap toward single pilot operation. So the purpose is not to get it fully autonomous, but to provide more assistance to the pilot, which would be a single pilot. And so for this reason, we do have to provide much more level of assistance than what is provided as of today. And that's why we push on the one side for vision-based navigation. And also you've seen this topic of virtual assistant in the cockpit that will help a lot also in the discussion with the air traffic control. And so we tried, in fact, to minimize the workload of the pilot through developing all these different assistants.
Right. Basically, the goal is to empower the pilot as much as possible, not to substitute the pilot with the algorithm, right?
Yeah. The purpose is
thanks.
the purpose. I mean, the business benefit is. I mean, now we have COVID for sure, but there is a global shortage of pilot, and it will be much more economic. It would be much more for airlines. It would be much more efficient if they would rely on one pilot, which is also a help given the fact that there is a shortage of pilots. So all these functions are serving this objective of single pilot operation.
Another question is about the broad spectrum of application of AI you've shown. Do you feel, or do you maybe focus your AI? Do you feel like it has some specific areas of expertise where you are especially strong, and how do you define it for yourself?
I mean, AI is a kind of buzzword, so there are areas.
The question was about your AI, right? So
No.
your own.
What I want to say is that for sure, I mean, the topic of some of our success have been achieved because we were active on image-based processing for years. So the topic of extracting information from satellite is not new. It's something we were doing for more than 20 years. But it happens to be that the recent technology linked to deep learning have enabled us to come to some level where we are really, I mean, we have achieved superhuman performance on several industrial use cases, such as extracting information from satellite imagery. So I think we are becoming, I mean, we have very strong skills in image-based processing as well as natural language processing, especially in Airbus defense and space. And these are areas where, we try to really keep our expertise to the best level. I want also to add that there are many, I mean, I've shown you stuff that are really the bright, that are the more easy to show, but there is a lot of gain also to obtain with quite simple AI on helping to find what are the outstanding actions to perform to improve the quality or whatsoever. So stuff that are less impressive on a presentation, but which also generate a lot of business value internally inside Airbus, and for which we also try to. So our objective is not to get the best of into AI. We really try to apply AI where it brings value, and if it could be simple, then we'll be happy to use it as simple as it could be.
Of course, even better. Okay, and that kind of brings us to the next question. When you say what you do, our audience is very much interested to hear how do you do that? Meaning that, well, the large manufacturing companies, they tend to struggle with attracting the right talent. Then even if you manage to attract the right talent in data science, it's still about how do you structure it? How is it like one data science unit for overall company, or you have data scientists in business units and so on? So how do you solve this? And are there any specific tools you use at the enterprise level to help you with that?
Yeah, I mean, it's we have a mixed approach. So we do like to have data scientists close to the business, because actually this is often the best way if we could get this kind of teams with data scientists and domain expert working very closely. So we form these multifunctional teams, and we have standard approach to do that. Also, for sure, we need to provide tools for these people to work properly. So we had to really renew the complete set of internal tools which we provide for these people to actually become good practitioner into AI. So this was done jointly with our digital transformation. And in terms of attracting talent, I think that's why I raised the point of showing that Yann Lequin is somehow looking at what we do, because ultimately this is the best way we are attracting people. We have very cool challenge. So to me, it is much more appealing than generating a recommender to tell you what is the best ad to put on a website. And also in terms of technology which we used, I mean, we don't have to be shy about what we are using in terms of technology. So we attract them through the challenge we propose and this is the way we try to retain them as well.
Yeah, thank you. So just to make sure that we got you right, for your tools, you develop them yourselves, right? So you have some in-house developed tools and platforms?
I mean,
or you also use some industry level?
I mean, we rely on, I mean, the digital platform. Skywise digital platform is based on Palantir technology. One Atlas digital platform is based on directly developed on the Google Cloud platform. We use a different cloud provider. I mean, for the Skywise is based on Amazon Web Services, but this is the storage aspect. Then storage on compute, but then we have really to build all the stack of to do analytics on AI, on machine learning ops. So all of that is something we did based on open source and also some tools which were provided by external companies. But we try, yes, to master that internally. Yeah.
Perfect. Thank you very much, Romaric. It was super exciting. I'm afraid we ran out of time. So I'd like to thank all our great speakers, Romaric and Thibaut. Thank you, guys. And of course, all of our viewers for their questions and their attention. So we are finishing our webinar now, but of course, don't forget, in the interim, we'd love you to engage with us via internet and our global community, which you can do at Twitter, tag @WorldSummitAI. And we look forward to seeing you next week and hope you all stay safe. Thank you very much.